Feels so weird that it's the end of this semester already.
Yeah.
I feel like so much time has gone by. Are you going to continue being a SI tutor next semester?
For this class,
Oh no, just for any class.
I don't know because my major is PME, so
Oh. So,
probably I'm gonna stay for the review for the 252. Yeah, if not, and maybe in the BME region, but not in other major, I guess. So any numbers fine, right? We talk about this one.
mm,
Okay, this one's the same, right? This one?
3,
This one? Okay. Let me find one on the book. So this is the use eigenvalue and eigenfactor to solve the differential equation in the system because we have both x and y. So the first thing is you need to find what's our a. So a is a parameter in front of x and y. So that's here. So for the first equation we have 1 and 2. So you put 1 here and 2 here. So 1, 2 in the first row. And here, for the second equation, we have 4 and 3. So you put it at the second row. So that is our A. And so in order to find the eigenvalue, we need to use this one. So A minus number times I equals to 0. So, and so I is the eigenvalue we are going to find. So that is 1, 2, 4, 3 minus. So I is 1, 0, 0, 1, right? And when you time the lambda, that is it will be.
will I always be 1,
Yeah.
0, 0, 1?
Yeah, if it's a 2 times 2 matrix, then I is 1, 0, 0, 1. If it is 3 times 3 matrix, then I is 1, 0, 0, 0, 1, 0, 0, 0, 1. So it's like a unit, it's kind of like a unit matrix. So there are only values at this part, and the others are all 0. And I always should be n times n. So that is I. And minus, so when you time lambda with I, you got a lambda here, and a 0, 0, and a lambda here, right? And you just subtract these two matrices, and you get 1 minus 0, 1 minus lambda and 2 minus 0 is 2. And here is 4, and 3 minus lambda. So this one, you got, because this equation should be equal to 0, so the value of this vector, you time it is 1 minus lambda times 3 minus lambda minus 2 times 4 is 8 should equal to 0. So in this case, based on this equation, you can find your eigenvalue of lambda, right? And then let's solve it. So this is equal to 3 minus lambda minus 3 lambda plus lambda squared minus 8, which equals lambda squared minus 4 lambda minus 5 equal to 0. And this is equal to lambda minus 5 times lambda plus 1 equals to 0. And you find your first eigenvalue equal to 5, and the second equal to -1.
I haven't been in school for a while, so I ended in first class of Laplace. So when you're done with her,
Oh, you missed the class for Laplace?
Yeah,
okay.
I missed all the last classes.
Okay, we can go through this after.
Yeah, let's finish it.
Yeah, we're going through. This is what we talked about last class.
I traveled last class.
Oh, okay. Well, yeah.
I traveled for a year, so.
Oh, you didn't attend last class too?
I didn't attend. I've not attended any classes. I missed the classes before the midterm, because I had a game. Then I wrote my midterm 2 weeks late. Then I traveled immediately after my midterm. So, yeah.
But it's okay. We are going through these problems, and probably we'll go another one, so you can know a little bit about this, because I think he's gonna talk more about the eigenvalue and eigenfactor.
Because he didn't get all the way through
it
in class.
So you can. This is I think probably. Okay. So after you find your 2 eigenvalues, and you put it back to that equations. So we are using, so because a minus lambda times I equal to 0, right? So when you time x, so x, sorry, it's not x, x is the value. When you time k, so k is the vector of 2 times 1, so we are assuming k equals this vector. It also should be equal to 0, right? And this one. So because we have 2 eigenvalues, we need to solve it one by one. So first, when lambda equal to 5, and you put back, so a minus lambda times I and times x equals to, you put lambda in, so that is 1 minus 5 is -4, right? So here is -4, and 2, 4, and 3 minus 5 is -2. So you got 2, 4, -4. So this matrix is come from this part, and this is not x. It's k.
When he did it, he put like a giant X and then an X.
Right?
Like, I was just wondering what the X was.
Okay.
That's what confused me. So I was like, I have
Because
no clue what this is.
So the big X is also a vector. So the big X is xt, a function of t, and the yt, another function of t.
So is that a different way of solving it? And will it solve it the same way as you're solving it?
Yes, it's the same way. I just so this is one value for x, and So because the final
Because the way that he showed us the x and then the x, then you take the derivative of it and then you get
Yes.
x prime.
that is I think that is he should like the values are given to you and you are verified that is the eigenvalue, right?
Okay. I think that's why I was getting confused. But I
Yeah,
was
they
like,
are
I don't
different.
know.
So yeah, for the first part, he's given you the eigenvector and eigenvalue, and you need to verify that this is the eigenvalue and eigenvector. So you put that value back to the equation, and you will find oh, it's so right is equal to the left. So that should be the correct answer. But for the second part, we are not given that, so we're going to try to find out what is the eigenvalue and the eigenvector.
Okay.
Okay, so I know for the first part they're a little bit confused because it's just directly jump to A and something. So for this part, so x prime is just a vector. So the first row of this vector is dx over dt, and this part is dy over dt. So that is x prime. So you can use any symbol, but it's and a is the parameter from in front of x and y. So we are going to find out the x. So x is a matrix which contains x function and y function. Right. So let's keep going. So once you put your eigenvalue in, and k, we are assuming k is a vector which represented by a and b. So we are getting and this value, this equation shows that on the right is all zero. So you put a vector that is 0 and 0, and you times two matrix, and you get. So for the first, so this one is 2 times 2, and this is 2 times 1. So when you multiply the two matrix, you need to use the first row times with the first column. So the first, so here is -4 times A, and plus 2 times B, which equals to 0 here. And the second row times the first column, that is 4a plus -2 times b, which is -2b, equals to 0. So we got two equations, and we can find the relationship between a and b. So because these two equations are exactly the same one, so we got 4a minus 2b equals a minus 2a minus b equal to 0. So b is equal to 2a. So at this point, you cannot find the exact value for a and b, but you can put any value for that. So if a is equal to 1, then b is 2. If a is 2, then b is 1. So our k here is a, b, and we replace b with a, and you can get a, 2a here, and then when you pull out the a, that is 1, 2. So the first eigenvector here is 1 and 2. So that is for lambda equals to 4 again, 5, and we still have lambda 2 equals to -1. So we are trying to find that one. So when lambda equals to -1, again we use the same method. So that is a minus lambda 2i times k, which equals to, we put lambda into this matrix. Because lambda is -1, so we get 2, 2, 4, 4. So here is 2, 2, 4, 4. And k is a and b, which equals to, so again, 0, 0. And you can find the relationship between A and B. That's 2A plus 2B equals to 0, and A equals to negative B. So A here is equals to negative B, B equals to negative 1 times B. So this is one of the eigenvector, and this one is another eigenvector. So once you find out the eigenvalue and the eigenvectors, you can write your the final answer. So x should equal to c1 x1 plus c2 x2. So c1 and c2 are just a constant. So c1 here is the first eigenvector, which is when lambda equals to 5, and the k1 is equal to 1, 2. So you put your first eigenvector here, and you time e to the lambda 1t. Lambda in this case is 5t. And the second value is c2 times the second eigenvector, which is negative 1 and 1. And the lambda in this case is negative 1. So you put e times negative 1t. So that is the solution for the x. So is that help you understand it, or is it still confusing? Did he talk about this in class, or he haven't reached there yet? Any questions?
So you pretty much, for the beginning part, you find the A, and then you solve it.
Yeah.
You solve this until you get what your two,
Mm-hmm.
and then after that, then you just do each one separately.
Yep, that is true eigenvector. So lambda, it's the same. Of course, I'm still choosing the same example. Okay. So the first step to solve this problem is, so these two equations are given. So there are two differential equations, and we are going to find the function of the xt and yt. So the first step, we need to find out what is our a. A here is just a parameter in front of x and y. So for the first differential equation, the parameters are 1, 2. So we put 1, 2 in the first row. And for the second one, it's 4 and 3. So we put 4 and 3 on the second row. Because there are only two equations, so the matrix of A is 2 times 2. Once we find out that, we need to find out the eigenvalues and eigenvectors. So in order to find out that, we use these equations. So A minus lambda times I should equal to 0. So A is 1, 2, 4, 3, and I is 1, 0, 0, 1. And when you multiply lambda and I, you get lambda 0, 0, lambda. And you subtract these two matrices, and you get this 1 minus lambda, 2, 4, and 3 minus lambda. And you find the value of this matrix by multiplying this and minus this. So you get 1 minus lambda times 3 minus lambda minus 2 times 4. And you get, once you get these equations, and you make it into 0 and solve it, and you're supposed to get two values, and that is lambda 1 and lambda 2. So these two values are the two eigenvalues. And in order to find the eigenvectors, you need to put the eigenvalues into this equation one by one. So when lambda equals 5, you put it in. So here that is 1 minus 5 equals -4. 2 and 4. 3 minus 5 is -4. And you use your k. So we assume k is one of the eigenvector. So the vector times this part, because this part is 0. So it should get 0 here. And so once you multiply those two vectors, we get so the vector should look like this. So the first row times the first column, -4a plus 2b, and that is 4a minus 2b. So this matrix should equal to 0, 0, and we can write in this formula. So this form. So we based on these equations, we can find the relationship between a and b. And once we find out the relationship, we put it back to our eigenvector, and we prove out either a or b, and we find this value. So this is the eigenvector for lambda equals to 5. And once we find out 1, and you use the same method to find out the second one. So that is -1 and 1. So let me write it down. So when lambda equals to 5, the eigenvector is 1 and 2. When lambda equals to -1, the eigenvector is -1 and 1. So once you find out this, you use the formula, which is this one. So x equal to c1 and c2. C1 and c2 are constant. And so x1 is the first eigenvector times e to the lambda 1 t. And the second value is c2 times the second eigenvector times e to the lambda 2. That is the second eigenvalue t. So we put all the values in this formula, and we get the final answers for x. So, any questions so far? And sometimes you may have I don't know whether we talk about that yet. So sometimes A is not a 2 times 2 matrix. Sometimes it's a 3 times 3 matrix. So in this case, that means you have a system which you have dx over dt and dy over dt. Again, another you have dz over dt sometimes. So based on this volume, we can know that dx over dt, which is the first row, so the first row of A is a parameter from the x, y, z, right? So dx over dt is 3x minus y minus z. And dy dt is the second row, that is x plus y minus z. And the third one is x minus y plus z. So this matrix represents the system look like this. So it is 3 times 3, right? And if it is a 3 times 3 matrix, you're supposed to have 3 values. Did we talk about this in class, or I don't know whether I have exceeded what he taught in class.
I think this is just.
Just give your values to verify.
He did the dxdt to ydt, and then we made an a, and then solved it. That's as far as he got with the 3x3s.
Okay, you didn't. He didn't.
He did. I don't think.
how to find the eigenvalues.
No, I don't think he went to that yet.
Okay, so then we can do this.
He like just started with eigenvalues only right at the end of class.
Okay, so then maybe that is. I think you have did you start doing the exam review one? No.
Yeah, that's fine.
But I don't know whether you have. Okay, let's do one of the solved exam. So the system of equations given is x equals 5x minus y, and y equals to 3x plus y. So the first things you need to do is you need to find out what is a. So a here is 5 minus 1 and 3, 1. And then you need to find use this formula. Formula times I equal to 0, which is 5 negative 1, 3, 1 minus lambda. I is 1, 0, 0, 1. And this is equal to so when you put lambda a, you get lambda here, right? And then you subtract these two matrices, and 5 minus lambda here is negative 1, and 3, 1 minus this should equal to 0. So that means 5 minus lambda to time them. 5 minus lambda times 1 minus lambda plus 3 equals to 0 because you minus 3 times negative 1. So that is 5 minus 5 lambda minus lambda plus lambda squared plus 3 equals to 0. And here you got lambda squared minus 6 lambda plus 8 equal to 0. And here is 2, 4. And this is equal to lambda minus 4, lambda minus 2, lambda minus 4 equals 1. And you find your two eigenvalues. Lambda 1 equals 2 and lambda 2 equals 4. And then you need to use your eigenvalues to find your eigenvectors. So when lambda equals to 2, we'll assume that k1 is equal to ab, and a minus lambda times I times your k1 is equal to, so this is your a minus lambda times I. So when lambda equals 2, 5 minus 2 is 3, and negative 1, 3, and 1 minus 2 is -1. And you time A and B to get, so the first row is 3A minus B, and the second is also 3A minus B. And this matrix should equal to 0. And find the relationship between A and B, that is 3A minus B equal to 0. And you can represent B with A, which is 3A. So K1 is A, B, which equals to A and 3A. And you prove out the A, you get 1 and 3. So this part is your first eigenvector.
You were moving like really fast, so
Oh.
you lost me at.
I'm sorry, where are
There.
Here.
This one.
This part?
The quadratic equation, yes. That's where I was.
Okay, so can you solve this equation or start?
Okay, yeah, I've solved that equation, so
Okay, so
starting from number 3. Yeah.
so you find out the two eigenvalues, right?
Yeah.
The first is 2 and another is 4. You need to use this eigenvalues to find your eigenvector. So we need to do that step by step. So first, we are going to find the eigenvector when lambda equals 2. So when lambda equals 2, we assume that K1 is equal to AB. Yep. And we use this formula because this part is 0, right? So when you multiply your eigenvector with this part, it should be 0. Right? So that's why I put matrix 0, 0 here. And in this case, lambda here is 2.
One question. Could you just go up a little? Yeah, I want to ask you a question.
Okay.
So that I wasn't there for the last class. So no, higher.
Higher?
So when you say A, is that A minus lambda times I?
Yeah.
Okay, so what exactly is that? It's just a random formula that's always
I?
equals to 0?
Okay,
Yeah.
so I is kind of like I think it's a unit matrix.
Okay.
So I is always 1, 0, 0, 1. If it is 2 times 2. So if it is
It's lambda times I is going to be lambda
Yeah.
0, 0, lambda. Okay.
yeah, you type, and if it is a 3 times 3 matrix, then you can write I as 1, 0, 0, 0, 1, 0, 0, 0, 1. So you only have values at this part. So this is a 3 times 3 vector. So that is I.
Thank you. I just wanted to be sure.
Sorry that I confused you. So you have
So now we're back to the third. Yeah.
here,
that one.
right?
Okay.
And still this vector will already get from here, right? So these are the same vector.
Yeah.
But when lambda equals 2, we can replace it. Yeah, we replace lambda here, and so that's we get this one. So 5 minus 2 is 3, and negative 1 is 3, negative 1. And we time our K1. K1 is AB here, and we get this one. So you use the first row times the first column, and the second row times the first column. So that is 3 times A, we get 3A, and plus negative 1 times B, that is negative B. So that is how I get this one. So because this matrix is 2 times 2 matrix, right? And this one is only 2 times 1. So when you use a 2 times 2 matrix, multiply with a 2 times 1 matrix, you're supposed to get a 2 times 1 matrix. You get rid of this part, and you get a 2 times 1 matrix. And this one is a 2 times 1 matrix, right? And after that, we have this matrix equal to that, and we know that 3A minus B equal to 0. And the second equation is also 3a minus b equal to 0. So we cannot get the exact value for a and b, but we can get the relationship between a and b. So 3a minus b equal to 0, and we get b equal to 3a. And we put it back to our K1, and we get a, 3a, and we throw out a, and we only left these parameters. So this is our eigenvector for lambda equals 2. So actually the reason I throw out a because remember for the last problem, when you get the final answer, you put a constant C1 and C2, right? So that A is contained in C1 and C2. So that's why I only get that. So, and we are done with lambda equals 2. And now, so we're going to find lambda equals to equal to 4. So the same method, a minus, I just directly write 4 here. 4 times I, and times the second eigenvector. You can assume that to CD or any just distinguish. And so this part, goes back to the matrix. So this time lambda equals 4, and we get 1, negative 1, and 3, negative 3. So that's 1, negative 1, 3, negative 3. And we can assume this is to be CD or something. And this one is C minus D, and this 3C minus 3D equals 0, 0. Again, we can find the relationship between C and D here. So C minus D equal to 0. C should equal to D. And our K2 is C, and that is, so that is C and C, and you throw out the C, you get 1, 1. So this is your second eigenvector. So once you find out the eigenvalue and the eigenvector, so lambda equals 4, lambda equals 2. That is 2 equals to 1, 1, and K1 equals to 1, 3. So based on this one, we can know that our x2 equals to, so remember the c times k times e to the lambda t, this formula. So when lambda equals 4, you get the value is c, that is a constant, times the eigenvectors. In this case, is 1 and 1. And you times e to the power of negative to the power of lambda times t. So lambda in this case is 4 times t. So that is one value for the system. And lambda 1 here is c1 times the eigenvector, which is 1, 3, and times e to the power of lambda, that is 2t. So the final x is x1 plus x2, which is c1 1, 3 e to the 2t plus c2 1, 1 e to the 4t. So that is how to find the so do you have any questions? So do you have any question about the eigenvalue and eigenvectors? Okay, let's do some Laplace transform. So still I'm trying to solve the I'm showing you how to so
It's in
Fs is equal to 1 over plus s, and we are going to find the So the Laplace transform of ft is given by this one, and we are going to find out what is the Laplace transform when you multiply an et in front of that t. So looking at this formula, and we need to recall from the formula of this one. So e to the at ft is so when you're taking the Laplace transform of the form look like this, and you get your Laplace transform as f s minus a. So and based on that formula, and we look at our question here, and we know that ft, when we transform ft to fs, our fs is given as this function, right? And when you time e to the t in front of ft, and here we know that our a is 1. And for the Laplace transform here, we just shift the Laplace transform to by as unit of a. So we can directly write this. We can directly write this as f s minus a. A here is 1, right? And for this part, because fs is given by this formula, so what we need to do is replace s here by s minus 1. So it's just equal to 1 plus s minus 1 to the power of 5. So this should be the final answer. So in this question, we are using the formula of this one. So, and let's do the
So, just one quick question. So A is because f of t is just
because here I'm getting a from here, right?
okay.
So a is a power of e, and here we only have e
One
to the
power,
t.
yeah.
Yeah, so that is how I get my a equals to 1. And once you find out a, and because here is s minus a, so you replace s with s minus a, and you get this.
Yeah, I understand.
And so that is 1 formula you need to remember. And the second one is, okay, it's here. So this is question 8. So given a function of ft equals to 0 when t is smaller than 4 and e to the t when t is greater than 0 and smaller than 4, and e to the negative t when t is greater than 4. So in this case, we can so in this case, our ft has to be 0 at the interval between 0 and 4, and start have like values after t is greater than 4. So we can rewrite this function as e to the negative t times a step function that is t minus 4. So our recall the step function. So when there is a ut equals to 1 when t is greater than 0, and 0 when t is smaller than 0. So this is your ut. And at here, if you get t minus 4, because here is minus 4, so you need to shift the graph to the right by a unit of 4. So you shift the ut to the right by 4. So this is ut minus 4. Because our function starts from 4, so once you multiply ut minus 4, and you get the 0, you get a value of 0 at the interval between 0 and 4. So that calls the ft start from 4. Is that okay? So after you rewrite these two separate together, and you get this one. And we are going to take the Laplace transform of ft, so which equals to e to the negative t u t minus 4. So, and so the second formula you need to remember is ft minus a times ut minus a. We will take the Laplace transform of this one, and you get fs e to the negative a times t. And so at here we have t minus 4, and here it has t minus a, so we can know that our a here should be 4. But at this part, ft here is ft minus a. It should be the same things at here, right? But for the question, we only have e to the negative t. So we need to make it look like t minus 4. So what I did is the negative t, you can write it as t minus 4, which is equal to this part. But you just plus 4 at the power. So you need to minus 4. So at here is the negative t plus 4 and minus 4 is still negative t, right? So these two are equal. But we have this part, which is what we want. And once you rewrite that, and you got e to the negative 4 times e to the negative t minus 4 times u t minus 4 here. because Laplace transforms are always linear, so you can pull out e to the negative 4 and only take the Laplace transform of this part. And cos a here equals to 4, and e to the negative t is 1 over s plus 1. So when we're taking the Laplace transform of this part, we can get so this part is 1 over s plus 1. Don't forget the e to the negative times. So when we take Laplace transform of this part is 1 over s plus 1, and for this part it's just shift the function. No, it's not shift. It's wait. I think I made some mistakes. Yeah. So based on that one, we get so this part is our fs, which is 1 over s plus 1, and you time e to the negative at. A here is 4 times t. It's not t. It's s. For s here, and you combine the e to the negative 4 and e to the negative 4s, and you get e to the negative 4s plus 1 over s plus 1. So this one is the answer for the Laplace transform of the function. We are using that formula. So, do you have any questions? So I think the most important thing for this question is how you make your function look like the form of the formula, and then you just replace all the variables of that formula, and you can get your final answers. So I think this one and the first one we're using is probably maybe confused, maybe confuse you sometimes. So once you are getting a problem, you need to know which formula, the right formula you are going to use. So that's why I put these two examples, and you can make a comparison. So and for the problem. So another one, so number 9. So number 9 is to find So for number 9, it asks you to find the inverse Laplace transform of the following in terms of convolution. So this is the Laplace transform, which equals to s squared plus 9 times 1 s squared plus 1. Okay, so for this one, if ft equals to gt and convolute with ht, And the Laplace, when we take the Laplace transform of this whole part, we can get the Laplace transform of ft equals to Laplace transform of gt multiply the Laplace transform of ht, and we can get fs equals to gs, which is the Laplace transform of gt, time hs. So, and back to the question here. We have the Laplace transform, and let's assume this is our GS, and this is our HS. So we're going to find what is FT. So based on this formula, we can know that our FT should equal to GT convolute with HT. So first step we need to do is to find what is GT. So GS here is given with S over S squared over 9. So GT should be, so these are the basic Laplace transform that you need to remember. So this one is cosine. Here you have S over S squared plus 3 squared. So that is 3t. And to find the ht, so hs here is 1 over s squared plus 1, and you get your ht, which is sine t, and then you can find your ft, which is gt cosine 3t convolute with ht, that is sine t. So that is your ft by using convolution. Any questions on this one? Okay, let's use Laplace transform to solve a differential equation. Your initial value is 2. So we're taking, so the Laplace transform of the derivative of ft is just s times the Laplace transform of ft minus f0. And based on this formula, we solve that. So the Laplace would take the Laplace transform of the whole equations here, and we get the Laplace transform of the derivative of x is s times x based on this function minus f0, and the Laplace transform of 5x is just 5 times x equals, so remember 1 transform is 1 over s, so 3 here, that is 3 over s. And because the given initial value for x0 is 2, so we can replace this part by 2. And we combine this part because it has xs, So that is s minus 5 x s, which equals to 3 over s plus 2. And you get your x s equals to 3 over s times s minus 5 plus 2 s minus 5. But your goal here is to find out xt. So you need to take the inverse Laplace transform of these equations. So the inverse of this one is just xt. And for this part is 2 times e to the 5t. Yep, 2 times t. Because so this one is e to the 18. We're taking the transform is s minus 8. So a is 5, so that is 2 times e to the 5. And for this part, we need to use partial fraction. Partial factor. I don't know how to say it.
Yeah, partial fraction.
Partial fraction. Okay, thanks. So for this part, you can write this as a over s plus b over s minus 5, which equals to s minus 5, and on the numerator is as minus a minus 5a. Plus b times s, which equals to s minus 5 minus 3. So you got your a plus b should equal to 0, and negative 5a is equal to 3. And you solve a and b. You got, so a is negative 3 over 5, b is 3 over 5. So you will write that one with s negative 3 over 5 plus 3 over 5 over s minus 5. And you take the inverse Laplace transform of this one. So the first one is just 3 over 5. And the second one is 3 over 5. So here is s minus 5. That is e to the 5t. So x is equal to 3 over 5 plus negative 3 over 5 e to the 5t, and plus 2 times e to the 5t. And you combine these two, and you get negative plus e to the 5t. So this is your xt. Any questions? So the basic things you need to know is you need to transfer this to Laplace transform, and but after you're making the Laplace transform, you need to take the inverse Laplace transform to get xt. So that is your equation. So first, you transfer your equations to Laplace, and after you solve it, you need to transfer it. You need to transfer it back in order to get the one question afterwards. So I think that's all the Laplace transform for the practice exam. Do you have any questions about it? So you need to remember some of the basic functions of the Laplace, like like if it's given to 1, then the Laplace transform is 1 over s. If it's e to the at, then it's 1 over s minus a. And you also need to know sine at, cosine at, so some basic functions.
Thank you.
No problem. So, everyone, something. Also, can you put your A number in it? Thank you.